addition, you usually have to infuse potassium to keep the patient from becoming hypokalemic, and it's dependent upon the insulin assay as to what the values actually are from center to center. So IVGTT is something that's been very popular and is easy to do if you do the cold IVGTT, in which you basically give a bolus of glucose, and here we have studies. These are in lean and obese adolescents in our center. You see the glucose responses are nearly the same with a slightly delayed decay. If you give a stable label in your glucose, you can actually look at the decay of that glucose, because this glucose is a mixture. This is all hepatic glucose production. This is a mixture of hepatic plus what you gave in the IV bolus. Over here, since the liver does not make 6,6-dideuteroglucose, this is the pure glucose that you gave, and you can look independent at the decay curve of that. And here's the key issues, and that is that the insulin responses to the same glucose stimulation are dramatically higher in the obese subjects than they are in the lean subjects. And I would point out here, the insulin responses here for our means of our DEXA-determined normal volunteer kids is somewhere in the neighborhood of 4 to 8 microunits per ml. Our obese subjects are in the 16 to 30 range, and so when you use a commercial laboratory that says the normal range is from 4 to 40 or 4 to 30, you have missed the whole game, because that normal population is made up of a number of individuals who have increased body fat. You can do the same thing looking at C-peptide and see the response here. C-peptide is a little slower decay because it's excreted primarily by the kidneys. All right. This is a way that we have challenged kids in the past looking at high and low fat content, as whether there was a difference between how kids burned these calories and whether there was some magic to this low fat calories. And these are relatively old studies, but they present some points of view here, and this is looking at the insulin sensitivity as determined by the IVGTT, and here is our lean subjects. And under a low carbohydrate diet, that is a high fat diet, 55% fat for 10 days, versus a high carbohydrate diet, which was 60% carb for the same 10 days in a crossover design method. So in fact, with exactly the same insulin secretion, the insulin sensitivities were increased with a higher fat diet or with a high carbohydrate diet, which must reflect adaptation to an intracellular environment and a post-insulin receptor increase in sensitivity or decrease in sensitivity. If you look at the obese subjects, the obese subjects have lower insulin sensitivity as measured by the IVGTT, but there was absolutely no bounce when we put them on the high carb versus the high fat diets, suggesting that whatever this mechanism of resilience within the normal individuals is actually blunted and probably has to do with accumulation of intravisceral intravisceral fat and intrahepatic fat and intramyocellular fat. And that's a whole discussion on its own. So its strengths are its reproducible measure. We've done the studies in kids. It's a very reproducible measure within about an 8% coefficient of variation of replicate analysis on the same individuals. It's relatively easy to perform if you don't add the stable label to it, and the cold model can be done with available programs. The weaknesses are it's expensive because of the insulin assays. Timing of the samples is absolutely crucial. You cannot be off a minute or two in those early decay curves or you'll miss it. If you use the stable label, you'll go crazy because we are going crazy with it. There's only one place in the world that does the analysis, and that's Dr. Cobelli's laboratory. And I think it's a meaningless sort of calculation, but we've got now 8 or 10 years of doing this into it, and I can't change. So I'm trapped because I want to compare to the old data, even though I know it's not what we need to do. Depends again upon the precision of your glucose and insulin assays, and it's critically dependent upon these measurements, okay? Because if they are not reproducible, your assay and your results will not be reproducible. So we've now sort of looked at 3 very unrealistic methods for doing any kind of epidemiological studies, but for doing very nice metabolic studies in a small number group. And then we've got this group of HOMA, Quickie, and just looking at insulin concentrations. HOMA is the homeostatic model assessment abbreviated HOMA, and it basically is a measure of the glucose concentration times the insulin concentration corrected. And it gives a measurement of insulin resistance. You can turn that back around by using a slightly different model, using the logs of the inverse of the log of the glucose and insulin, and that gives you an estimate of insulin sensitivity. They aren't exactly the same when you get down to it and do comparative studies, but they basically measure the same thing. As the numbers go up in one, it's insulin resistance. As they go into the other, it's insulin sensitivity. So you have to make sure that you remember what you're looking at. The fasting insulin, I think, is an awfully good measure, as is a fasting C-peptide, as long as the blood sugars are perfectly normal to measure this. So this is just some comparative data on the same group of kids, looking at just plasma insulins. Here's the normal and the lean on the low carbohydrate and on the high carbohydrate diet. And here's the obese. Almost a threefold difference in terms of measurement of insulin at euglycemia. So these kids are about 3 times more insulin resistant than are the controls. If we look at just insulin to glucose ratios, you'll see we have almost a threefold increase in insulin resistance by that measure. If you look at HOMA, you see about a 2.5 to threefold increase in insulin resistance by using HOMA. If you look at Quickie, again, it's the inverse. They're much smaller numbers, so these are probably out another decimal point. Very highly significant decrease, which is decrease in sensitivity or increase in resistance. And you can't do the fold change here as you can here, but the method does the same thing. And here's our stable label IVGTT. It looks like a format. So you can see here there's a 2-fold difference, and here's almost a 3-fold difference on the diet. So again, altogether, we can measure insulin sensitivity a whole bunch of ways, and it depends on what works best for the kinds of studies you're designing and the questions you're asking. There was always differences between the two groups, and if you compared HOMA to Quickie fasting insulin, and insulin to glucose, any of these combinations were not significantly different. So they're all measuring the same thing. You need to know what the question is you're answering and the type of study you're doing to be able to use these techniques correctly. There's a study by Dr. Arslanian comparing her clamp studies with all of these methodologies of HOMA and Quickie, and basically the bottom line is they're all equally good, but those who do clamps are religiously attached to them, and they will never give it up as being the gold standard. So you have to just keep that in mind. Strengths, these are easy to do. They're relatively inexpensive. They're useful for epidemiologic and large studies, and they are not necessarily operator dependent unless you have different insulin assays. No measurements of insulin secretory capacity, not specific for peripheral resistance, cannot measure hepatic insulin sensitivity. It's critically dependent on the accuracy of the insulin glucose assays, as are all of these. So, just one last slide. We're looking at insulin resistance. It's brought on by weight gain and obesity, inactivity, age, medications such as growth hormone and glucocorticosteroids, increased plasma-free fatty acids such as in TPN or in obesity, inflammatory states in which there's adipokine abnormalities, and genetic factors that have to do with muscle mass and relative body composition, and defective insulin receptors, which is the early point that we looked at. So why is it important? Insulin resistance leads to acanthosis, prediabetes, type 2, dyslipidemia, hepatosteatosis, PCOS, and hypertension. Other than that, it really doesn't do much. I think that is the key point that we're trying to address, and the idea here was to get some ideas about how to measure it and what would be accurate for the kinds of studies that you're doing. Thank you.
So, Hayat, do you think we have time for questions? Okay, so let's open this up for a few questions from the audience. For both of the speakers, yes.
Go on, Suzanne.
Any questions?
Yes.
don't know how long we're going to take for.
I'm fine.
Yes,
I need to stand up after last night.
I have a question to Susan. I just want to ask about the studies or the statistic that you presented for the diet center.
Yes.
I just want to say, when you said less than 18, what's the minimum age you see in diet center for kids?
Minimum age is 8 years old, but most of them are between 12 and 18, basically.
And, you know, as you said, there's a recommendation that behavioral adjustment and this. Do you do that in the diet center, just you, mainly nutritional?
No, this is one of the main targets of the diet center, is to change the behavior of the family and of the child, because we consider it's a two people that are we have to tackle the two problems: the home and the school and the child himself. So we give a lot of hours for the child to come for the follow-up every week to the center, and to ask him about his food choices. What do they learn from the week before? What they want to adjust? What they have questions? And we have a record, a follow-up, a record of every week until we reach the target weight. And then the most important thing is a weight maintenance plan, which we are not successful if we don't do it. So we do it regularly for every patient.
And just a last question. Do you do the weight maintenance? Because as I know, your program is monthly. You need to pay per month.
Yes.
So if the child or the whatever, he just commit himself to one.
Yes.
To 1 month. So you cannot do a maintenance
No,
program
what we
anyway.
do is we will do a weight maintenance. It's a written structured diet. It is a weight maintenance, and they will come for it free of charge every week until they finish.
Okay. Thank you.
I just add one comment. The problem is not with the comments that, or the information that is being given. The problem is with the reaction from the client. I mean, we give the information, we offer the follow-up, and we offer all the basically tips for behavior modification, but unfortunately we don't really have the expected reaction from the client.
And I need just to add also, when we have emotional problem between the child and the parent, we ask the parent not to come in with the child, so that we can talk freely and see exactly what's the problem with the child.
Professor Bauer.
I would like to ask Dr. Haymond about, or I'd like to comment. Thank you very much for a very clear overview of the issues, the challenges with measuring body fat and insulin action. I was wondering if you could comment, because in the end we're dealing with, simple fasting blood tests for a lot of epidemiological studies and for actually clinical situations. Can you talk a little bit more about the challenges with using just a straight-off fasting insulin in clinical practice? Something that we do, but I know has a lot of challenges. I was wondering, I'd be interested in your
I think
thoughts.
it's a very simple does not mean easy. Okay, I think is the definition. We went out with a healthy study into the school districts of Houston and Drew, did oral glucose tolerance tests on almost 450 kids, and we got the numbers back, and there were a number of kids who had fasting high glucoses, but their 2-hour glucose post-challenge test was perfectly normal, and it was probably 15% of the kids, and we just plain think those kids ate before they came. So you never, unless you're controlling the meal intake and know exactly how long they're fasting, the fasting glucose is only as good as that piece of information. And it's a problem when you're doing large studies, because if you get a 10 or 15% group that are not complying, your mean changes and your standard deviation goes way up. So it means you have to study that many more patients to get a statistical difference. And that's why many of us who do these studies, not epidemiologic studies, bring the kids in overnight, because we know exactly, and we have these special study units that are general clinical research units where we actually know what they got to eat, because it's far more expensive not to bring them in and have bad data and not a good answer to the question. In an epidemiological setting, it's very, very difficult to know whether the child has eaten, or the individual, doesn't have to be a child, adults lie just as much as the kids do, as to what they just ate. Just ask me what I ate last night. I just had a small salad. So that is the basic challenge of knowing what you're dealing with and what the duration is. Other issues are what have they consumed in the previous day or two. In the States, we have to be concerned in primarily adult populations that have been drinking, and are there other factors involved in that? So those are all issues that make it very difficult to use a single blood sample as the test, but it still is the cheapest, singlest way. And if there was a way of proving that they had eaten a meal, you could throw that data out and you could be back to at least a valid group of people. So when we do studies, we generally pay people to volunteer for an inconvenience fee because they're inconvenienced to come in and participate. I turn that around and look at the kids and says, I'm paying you to follow the instructions, okay? If you don't follow the instructions, I'm not sure I can pay you. Well, that's not legal. I can't do that. And Christina's going to turn me into my institutional review board when I get back. But the idea is to try to motivate the patient, to have them understand that their participation and how they participate is, in fact, crucial to the understanding of the study. So, is that...
Yes, one last question.
Yeah, I have a question about the insulin
left.
resistance. Usually we talk about the last time